Welcome to our first lecture. In this lecture, we discuss about kinematics in one dimension. In kinematics, we try to explain motion without using the forces. We use position, displacement, velocity, and acceleration to explain the motion. First, try to understand what position is. Position is the location of an object relative to the origin. In this picture, you can see the 0, 0 represents the origin and x0 represents the position of an object. So this vector x represents the position or the position vector of the object. These examples show how we can represent the position. Two different representations. We can represent the position in terms of coordinate. 5 meters and 0 meters are the coordinates, x and y coordinates of the x position, or you can represent in ij form. Since it's one dimension, we use only I is a unit vector in the positive x direction, so 3i meters. So 3 is the magnitude of the vector, I represents the direction, which is the positive x direction. I is a unit vector in the positive x direction. Then the displacement, we represent the displacement by delta x. Displacement is the change in position, or we can represent delta x in terms of x minus x naught. X is the final position, x naught is the initial position. So in this diagram you can see the initial position vector and the final position vector and the displacement vector. Velocity and speed. The average velocity is defined as delta x over delta t. Delta x is the displacement. If you divide by the time interval delta t, you get the average velocity. And same way we can define the average speed, which is the distance divided by delta t. The difference between the two is the average velocity is a vector, but the average speed is a scalar. That means the speed doesn't have a direction, right? The vectors have a direction and a magnitude. And also we define the instantaneous velocity, which is defined as dx over dt, the derivative of x with respect to t. And the other parameter is the acceleration. The average acceleration is defined as delta v over delta t. Delta v is the change in velocity, delta t is the change in time. Also we can talk about instantaneous acceleration, which is again the derivative of the velocity with respect to t, or dv over dt. So the parameters or the physical quantities that we discussed are position, displacement, or distance, velocity, speed, and acceleration. Position, displacement, velocity, and the acceleration are vectors, and the distance and the speed are scalars. When solving problems, we use 4 equations. We call them equations of kinematics. When deriving these equations, we assume that the acceleration is constant, so we call them equations of kinematics for constant acceleration. The first equation is v equals to v naught plus at. V is the final speed, v naught is the initial speed, plus a is the acceleration, t is time. And the second equation is x equals to v plus v naught over 2 times t. The third equation is x equals to v naught t plus 1 half at squared. And the fourth equation is v squared equals to v naught squared plus 2ax. In the kinematic equations, x means the displacement, not the position. Okay, so that's the difference